Okay, well, that was easy. Let me get my notes here. My notes have disappeared in the meantime. Okay, well, thank you for attending the session. This is my presentation on using structure in taxonomy based auto-categorization. My name is Ahren Lenhert. I work for Synaptica. I'm the senior manager of text analytics solutions. I've been working in this space for about 15 years doing text analytics, search. Mostly my focus has been on taxonomy and ontology management. And I've been with Synaptica for nearly 2 years with a focus on text analytics solutions. So I'm going to frame the conversation here by using one example, using the term Saturn. So the term Saturn has multiple meanings depending on how you want to use it. We, of course, have Saturn the planet. We have Saturn the automobile, comma, defunct. We have Saturn watercraft, comma, obscure. At least to me, they are obscure. They might not be to water people. We have Saturn V vehicles. We've got Saturn astrology. And then we've got the extra creepy Goya version of Saturn over there eating his children. So we have all these examples of Saturn. The question is, in a mixed domain environment, how do we disambiguate the same or similar concepts? We know this is something that sort of plagues us. How can we then use various structural levels to disambiguate and figure out which term it is that we're talking about? Well, we can look at the objects orbiting the concept. That's a very clever pun. We can use existing structures and impose artificial structures in order to figure out which Saturn, in this case, that we're looking for. Okay, so I kind of used Saturn as my example here because it's this very nice metaphor that you have all this debris and chaos of language surrounding the object of interest, right? In this case, we're kind of interested in the concept Saturn, and there's all these other words around it, this debris field of language, and we're trying to figure out which Saturn, in this case, that we're looking for. Okay, so we can move from chaos to chaos. I think it is very, very funny that the acronym for Knowledge Organization System spells chaos. I know there's not a dash in there, but I always like to pronounce it that way. So let's talk about moving from chaos to chaos. The first level is talking about using a knowledge organization system of taxonomies and ontologies. Another level is, of course, using natural language processing and text analytics. And finally, we can use document structure inherent in rendering text for visualization. Okay, so we're using these three components to move to something that's less chaotic. Okay, so taxonomy structure. So a taxonomy structure can provide the hierarchy and the relationships to other terms which can become imposed on the structure, providing meaning. So in this case, we have Saturn the planet. Saturn this is from the NASA thesaurus. It's under planets, as you can see. That's its top-level parent in this particular hierarchy. Above it is gas giant planets. And then we have its siblings, which are Jupiter, Neptune, Uranus. We also have the other things that are related to it. So in this case, there's this whole list of, a lot of these are natural satellites that orbit Saturn. We have other things in there as well, like the Cassini mission, and various things that are related terms to Saturn. And finally, we have other things that also provide context, like other planets, like hashtag fake planet, hashtag Pluto planet, and it's interesting you brought up BoJack Horseman. I am a big Rick and Morty fan. So here is Jerry Smith telling us Pluto's a planet, which I agree with. Okay, thanks, Jerry Smith. Okay, so when we move from syntax to semantics, we can create a taxonomy or ontology as another structural level to employ. So typically a taxonomy can be built in advance. So you have one in your organization, it is sitting there, it is waiting to be used to provide context. In other times it is built from scratch. We look at the content, we pull out items, we build a taxonomy from that. Usually these two things are done in conjunction. You have a taxonomy, you look at content, you pull out concepts, you add it to your taxonomy, and you manage it, and then you might go back and auto-categorize back to the content. Okay, so I consider a taxonomy a very artificial construct. These are terms that have been pulled out of context. We have put them into a tree. It's very unnatural when you think about it, you know, that we have created these hierarchies. It's very artificial. We are imposing a structure on the language, and then we are imposing that structure onto content. The advantages of taxonomies, of course, is they formalize these preferred terms. It's the meaning that we want. This is the thing that we want to address. But it also allows variants, such as synonyms. We get related terms, and we get this whole structure that we can leverage. So the term placement in the taxonomy determines their role in text. So we can have preferred terms, related terms, siblings, etc. So taxonomy and rules structure. If you have seen Tom Reamy speak, which I'm sure you have, he uses the term for this a catonomy. So I will help boost his traction, #catonomy, which is the taxonomy with its associated rules. We have the categorization rules and the terms themselves. Okay. So in this case, I am looking at the main preferred term, which in this case is Saturn, and I've got other document keywords. Now I've added a couple here in this particular image. I've got the second largest planet, I've got the sixth planet from the sun. These are all terms or expressions, phrases, that you might find that are basically synonyms for Saturn. We also have positive context keywords. Now you can automatically create these from the structure of the taxonomy, or you can manually create some rules. And these are positive indicators that this is the Saturn that you're looking for. You see these other things in the text. This is probably the Saturn we're looking for. And down below, we have negative context keywords. Here we're using things like automobile and Chronos and Saturnalia to disambiguate and say, you know, I am interested in the planet. In my context, I'm not interested in the Roman god. I'm interested in this version of Saturn. The final thing you can see up there, the require same sentence. This is where we're starting to bridge the structural levels of taxonomy with the structural level of language. We're saying that we're going to bound this within a text boundary. We're saying within this sentence, if you see these two things, this is probably a positive or negative indicator. And these boundaries can be bigger, they can be smaller. So let's talk about the next structural language. I am not a linguist. I've taken some linguistics in the past, so thankfully they've done a good job ahead of me talking about through some of these details. Hopefully I haven't made any embarrassing mistakes. The next level that we want to discuss is language itself, and that's what text analytics is all about, right? Natural language processing. That's always been the linguistic basis. We're looking at the structure of language itself. So now we've had artificial structures like taxonomy. Now we're looking at the natural language structure. So I'm not going to make this a lecture on linguistics, as I said, but we have things like nouns, verbs, and adjectives in the language that we can sort of parse out and understand what these things are to give us another structural level. So, you know, the basic structure, and I know this is very basic, in English is subject, verb, object, and this is common in a lot of languages. It's pretty simple. We base the, if you're familiar with ontologies, this is the same idea with subject, predicate, object, right? We're just mirroring the two things. We've got some kind of subject like nouns and pronouns. We have verbs, and there are various types of verbs, and there are objects, various types of objects. And then we have other parts of speech. As you can see, these are sort of high level. I didn't get into a lot of detail because there are so many parts of speech. But for a native speaker of English in particular, we can break linguistic rules. We can mix up the words and still be understood, right? So, for example, we understand Yoda, even though reversed often his word order is. We still know what he's saying, right? Computers, on the other hand, aren't really going to get this. So we need to pay attention to the structure of language, use that structure to be able to parse out semantic meaning. Okay, so far we have covered taxonomies and ontologies, and we have covered natural language processing. Now we can talk about the other structural level, which is the document itself. So we can leverage document structure because we render text electronically by using structure. In order to get it into a format where we can read it. We're using things like markup language. This excuse me, this Wikipedia article, for example, has different elements. We've got a header, we've got paragraphs, we've got links. The whole thing, we know that this is structurally a Wikipedia article. They use common formatting in Wikipedia. We have a table of contents. So what can we do with that? Well, let's look at the document markup. So this is what document markup looks behind the screen, behind the scenes. You can go to view source and look at this. A lot of us don't want to look at this. I think most people in this room probably understand you could kind of parse through this and look at the HTML and say, I kind of know what's going on, even if I'm not a programmer. Here, for example, we've got the term Saturn. It's got the P paragraph symbol. We know that that's how it's marked up. It's in bold. And we have a slightly more complicated markup with, we've got a class, which is of table of contents. And that markup language is rendering that document, showing us what it's supposed to look like. So we have the document text itself. So here we are with the same article. This is what it looks like to us on the screen. We can leverage that as well, and we can say, okay, well, there's that term Saturn. It's in bold. There's that term contents. I can look at this and say, okay, I'm starting to see the structural elements. Now, this doesn't really exist in unformatted text. When we get to a TXT file, not a lot of markup to work with, kind of are reduced to the words themselves, the language themselves. So we still have Saturn, we still have contents. The bolding has gone away. I may have lost some of the structure. This one rendered pretty well, but a lot of those elements have been stripped away and I can't use them. That all said, we can create document sections. And again, this is the third level of structure that we can impose. So we could use the markup structure. So if you look at the left there, I've got a document section I've created. It's called heading 1, and it's got a tag. It's H1. And so I've said, hey, when you see H1, that's a heading, and it's a document section. I think that's an important document section. So then if I start to put these things together, I'm saying if you're finding this term in this document section, well, we're probably going to weight it a little more heavily. A heading is important. Search engines do this. They typically weight titles and names and headings more importantly than the body of the document. If you look at the one next to it, I have defined a section called references. Now, I've given this a score of 0, or a weight of 0, rather, and I've said don't annotate it. I have been able to distinguish all of its various properties that make this OL tag a references section, and I can choose to do something with that as well. So, one more document section. We can do things like look at the text and look at the body. So we had some markup. Not everybody is necessarily good with markup. You have to look behind the scenes. You have to know what's there. But what I can see is the rendered document. So I've created a document section here called Introduction. And the introduction, I said, from the start of the document until you see the word contents is my introduction. And I'm going to weight that very heavily because that's important. Usually the main idea is in the introduction. This is true of news articles. And I've created a document structure that has a document section structure that's repeatable, right? I can use this. All Wikipedia articles are using the same markup and the same structure. So I can say, well, I've just created a document section that applies to any Wikipedia page. In that introduction, if you find these terms, they're probably pretty important. Okay, so back to moving from chaos to chaos. So what I've identified here in this section of text is I've got my main terms, my preferred term. I have my related terms, which in this case happen to be Titan and planet. They're in the same sentence. And in this example, I don't know if you can see it very clearly, but I've clicked on the term Saturn, and it lit up those other terms green because it's saying, okay, this is positive context. This is probably the Saturn you're looking for. You also see a little bit of NLP, sort of mixed in here. I've got the term Saturn. It's highlighted. The apostrophe S has been stripped off. I still recognize that word is Saturn, even though it's Saturns. It's a possessive. It's ignored that, right? So we're getting the NLP layer in here. And we're also getting the document section layer. So I've added these document sections. I've sent all this stuff together. And it said, hey, look, in the heading I found the term Saturn. What a surprise. The article is called Saturn. I find in the introduction, hey, I found the term Saturn. I found the term Jupiter. I found the term Neptune. So I found all these related terms. There they are in the introduction. And I've weighted them quite heavily because you said the introduction was important. And here's my references section. So my references section, for one, it doesn't render all that well. For two, I look at the references section of a Wikipedia article and I really don't care. This doesn't give me a lot of information. It's nice for references, but it doesn't tell me the aboutness of the article, really. So when I set up the references section, I said, don't annotate it. Don't weight that. I want you to ignore it. Ignore all instances of Saturn or these other terms, because I don't want that biasing the whole thing. This is a very big section. I'm going to blow that out of there. I don't want to pay attention to it. I only want to pay attention to the sections that matter to me. Okay, so in summary, we define 3 levels of structure. The first one, again, is using a knowledge organization system of taxonomies and ontologies to create this sort of artificial layer of language of preferred terms. Then we have the text analytics layer, which is really getting in there, and we're doing things like tokenization and lemmatization, and we're pulling apart the language, and we're identifying parts of speech. That's a real backbone to doing these other things. Then we have the document encoding and presentation. So the document structure itself, again, whether it's highly marked up in markup language or whether it's text, it doesn't really matter. I can define document sections. When I put all these things together, I get a lot better information and a lot more semantic meaning of the term that I'm looking for. Any questions? We're going to open it up. I think we've got quite a bit of time here. We're looking at, oh no, it's 11 o'clock right now. I think we have time for at least 1 or 2 questions. In the back there. Well, that depends on how it got scanned, right? I mean, if you have an image, that's kind of a different problem, isn't it? Because you can't get into the text. Yes, so she's asking about, what happens when you have an image. That's really a different kind of technology. So, in this presentation, I'm talking about being able to actually get into that language. If you have an image, then you're talking about image classification, a different kind of technology where it's identifying within the image itself. So you need to OCR, you need to pull those out and get into a format that, a lot of text classification tools need a format where I can get into that text where it's not OCR'd. Yeah, back there. Yeah, so I've been a taxonomist a lot longer than I have been in the vendor space. There's a lot of different ways to start. I know that you can take a body of content and you can do entity extraction and pull out elements. I sort of divide the world into 2 parts here, the known and the unknown. You can take that unknown content, pull out elements, and start to structure it into a taxonomy. There's software that does automatic taxonomy building. I'm always a little skeptical of that. I don't want to say anything too badly about it, but you can extract things and they might come out as a list. They might have some hierarchy and some clustering to various degrees of success. Usually you need that hybrid approach where I'm not going to read and manually index these and pull out all the terms myself. I'm going to use a machine to do that, and then I'm going to manually curate that into a taxonomy. And it's always a build versus buy question too, of whether you just want to go out there and buy a taxonomy and modify it to your advantage. Typically what I've done in the past is I've gone in and I've set up a very top level structure, and then conducted workshops, and I said, hey, here's what I think sort of generally suits this organization, a faceted taxonomy. Fill in the blanks. Tell me about these different facets and what kinds of terms we should put in there. So there's lots of ways to sort of gather that information and build a taxonomy. Jeff?
My question is mainly for Kiki and Shana, but you can answer it too. It's about the structural approaches in general and how language is the main dependent on it. So for all this top word stuff that is fascinating, how much of it do you think is specific to language, English specific? How much of it is specific to domain and the kind of stuff you're doing in Reddit versus other areas?
So we have used this languages and across pretty much every domain. So you can see some work by Ryan Boyd on authorship identification, using function words to look at authorship attribution in Shakespeare plays. And that's, going all the way from there to modern blog articles, Twitter, really any context, any language. The one thing is that everything has to be kind of rebuilt and re-researched from the ground up in any new language, because what a particular pronoun or a particular conjunction means when translated into another language, what it means psychologically may not be at all the same. So, nothing can be directly translated, but the concepts hold.
But formal or informal language, same applies, different cultures, same applies.
Very interesting. I think we're a little bit over, but I think we could take maybe one more question, if there are any.
About the second part, the second two, when you talk about subject, predicate, object used for recognizing what kind of Saturn is that. Can you go a little bit more in depth how does it work?
Well, I was sort of, so he's asking about this subject, predicate, object. I'm talking about ontologies. Now, a lot of the work that you saw, the examples there, was really based on a taxonomy. We're not getting into advanced relationships. It's basically hierarchy-related terms. Of course, you can define your own kinds of relationships, so it's a little simpler. I think that we have not been doing this work yet, but we intend to. By we, I mean the company I work for, where I would want to leverage those relationships and the nature of what that specifically defined relationship in ontology was, because that's much deeper. Then you're talking about, you heard presentations this morning about knowledge graphs. That's getting much deeper, where you're leveraging that more complex ontology structure to create the semantic meaning.
You're talking about triple in the actual sentence or only in ontology? Or ontology somehow can catch the
I'm not sure I quite understand your question.
About that, subject, predicate, object, as in the ontology, not in the part of the speech. Using an analogy.
Oh, I see what you're saying. Yeah, I'm sort of using an analogy there that, obviously in language, typically a structure is subject, verb, object. That makes essentially a complete sentence, but the parallel is there, right? I mean, in an ontology, the predicate is basically a verb, right? It's, product has owner, which is sort of that verbal that verb structure pointing to the object of whatever the object is. Those two things are mirrored, yeah. Okay, thanks. Well, thank you all for attending. Please come up and ask additional questions. This is a very fascinating presentation, and thank you to the speakers. Sounds kind of self-congratulatory, but thank you all for attending.